So this is a problem that I am saying that it will be slightly different from the previous problem that you are accustomed to solving. So basically, you have a two masses connected still by a single string over a pulley, and each of the masses also are inclined at different angles. So I will call this one the 100 kilogram as my mass 1. We'll call that M1. And my second mass or mass 2, M sub 2, is the 50 kilograms. Now, M1 is inclined at 30 degrees, and is placed on an incline at 30 degrees, and also in the same manner, although at a different degrees, at 53.1 is your M2 also inclined there. Now, the first question that is being asked is, which way will the system move when the blocks are released from rest? So assuming that this is the initial state, you are going to think which way the blocks will move. Now, obviously, you are seeing here that mass 2 is the one on the left-hand side. And since this is more massive, once this is set to motion, the tendency for this system is to move towards your left direction. That means the acceleration of this object will go in this direction. In the same manner, these 50 kilograms also, since that is connected to a string with mass 1, it will also move with the same magnitude of acceleration A, going upward in that direction. So that this is very essential, as I've said from the previous video, that you are able to think what will be the motion of the system after some things are set into motion. Okay, so we have already answered this first question here. So which way will the system move when the blocks are released from rest? It will move towards the left-hand side of your 100 kilogram in the case of mass 1. And in the case of mass 2, it will move upward also. Okay, now for the second question, it asks you of the acceleration. So what is the acceleration of the blocks? And we know from, hopefully by now, you came to realize that the acceleration of the two blocks will be the same, since they are basically just connected over a single string, and whatever the direction of the acceleration of A, as I've said, that will also be the same acceleration that mass B will experience, or the 50 kilogram will experience. And the third one is it asks you of the tension in the cord. Now, basically, the very first step that we are going to do when we are dealing with these problems is to set our free body diagram. Now, what I would do here is I will create two separate free body diagram. And the first thing that I'm going to do is to set the new coordinate axis for my free body diagram. Let me just erase that one. So here, I will have the y-axis. I don't know why it's not moving straight. Yeah. So that will be my y-axis. I will set this one as my y-axis, and you will get to see the reason why later. And my x-axis also will be situated along the direction of my tension, or along with the direction of my connected string there. And also, if you remember, assuming that the mass is concentrated at the center of this object here, mass 1, so our entire mass is, we could assume that it's concentrated in its center, and then you have to take note that the direction of the mass, which I will write in a different color, say blue, will always be towards the center of the earth. Therefore, in this case, from the center, it will be moving, the weight, sorry, I'm talking about the weight. The weight will always be towards the center of the earth. Therefore, from the center of this mass 1, you draw a straight line directly going downward to determine, or that will determine the direction of your mass W sub 1 in that case. Okay? So and also you have to take note that since there is a contact between your surface and your mass M1 with 100 kilograms, you have to factor in that there is an existing support force or the normal force in that case. And also another force that you can see there is the tension due to the string. Now take note, we always ask of the question, where is the string pulling? In the case of mass 1, the string is actually pulling in this direction towards here. So I will situate my tension 1 in that direction. So right now, this is still quite not really friendly to the eye, but you will get to see this one simplified, and like translated in a more friendly manner later. And then also, I will not show it in this class, but I am hoping you get to see or you get to understand from your geometry classes that if this angle here is, you're seeing there, that is 30 degrees, in the same by some laws of geometry, you will be able to see that this angle here is the same angle that is given above, which is at 30 degrees. Okay, now let's move to the second object. So the same thing, I will be drafting, or I will be situating first my one of the coordinate axes that I have, which is the y there, and another axis here along the direction of my tension. And as I've said, this will all make sense to you later why I did it in that manner. So if you try to look into that one, the same, although in this illustration class, it's not really like perfectly illustrated. But assuming that this is where your center of mass of your object, although if this is uniform, dapat sa geometric center gyud. So forgive my illustration. But assuming if that is the center of mass, so we know from the center of mass where all of the mass of your object could be assumed to be concentrated, you draw a straight line going downward to indicate the weight of that object, since we all know that the weight of the object is always towards the center of the earth. So I will denote that as weight sub 2. Now, in the same argument that I have earlier, if the angle given is at 30 degrees, now the angle here, kini siya nga angle class, this will also be the same angle as 53.1 degrees. Okay, so I will not go over the proof, so this is up to you to review your geometry classes. Now, you need to take note also that there is another tension, or I don't know if I should say there is another tension, but for the case of mass 2, na ay action sa string na nagpula na niya padulong diri, I will call that tension 2. So another question sa pagsulat pa lang that you should ask yourself, are the two tensions equal ba in magnitude? So that's something that you have to ask, because that will be very relevant to solving this problem. And then also, since there is a contact between your plane and your mass, dili kalimtan na to nga perpendicular to the contact is your normal force na atay n dira. So right now, it's not really, like if I'm going to look into that one, I would be annoyed with how it's looking, and it's quite complex yet. So we are going to simplify the free body diagram, and what we are going to do is to do some rotation of our axis. So for example, and this is where I am saying na masimplify na dayon. This is where I'm saying why I situated those coordinate axis na ko in such a manner. So for your mass 1, what I'm going to do, take note, mass 1 is the 100 kilogram there. So I'm going to rotate this one. And if I could rotate this. Okay. If I'm going to rotate it in that manner, so you see, this will now become my x. This here will become my x-axis. This direction will be my x-axis, and this direction will be my y-axis. So I could write a very simple and a clearer na free body diagram below. I don't know why, but there's some dislocation that is happening here. Yeah. So I'm hoping you get the point of why I'm doing it in this manner. So kini na ako mga forces sa x, kini na sa akong y. So I'm just going to return this to its normal orientation because it's affecting the bottom part. Or maybe I should erase this portion first. Undo na lang tayo. So let me undo this first. Okay. So basically yun ang ginagawa ko, class. So ang mangyayari sa nakita nyo kanina, this will be the normal force N, and then you take note that I'll use a different color. You take note that the weight is already hindi na siya going downward na diretso, kundi it already has a component because it's already having an angle. Kasi sa sinasabi ko nga kanina, you need to rotate this one. Tapos pag rotate mo, this will be your forces along the x dito, along the y, at saka dito yung bagong x-axis mo. So yun yung gagawin natin para sa ating free body diagram. So I will undo that one. So ang mangyayari, mayroon tayong a normal force going up, and then you have your tension 1 in this direction, T1. And then, okay, you need to note also, just for the sake na correct yung direction nyo later, that the acceleration is going in this direction. And then, you have these components na karon. This is your, if this is weight sub 1, this is weight sub 1 sub x. And then, this portion here is weight sub, weight sub 1 sub y. Meaning the x component of your weight 1. Did we took into account all of the forces for mass 1? I think so. Normal force, weight, yeah. Because also it's assumed in the problem that there is no friction existing between the pulleys and the string as well as the material and the plane. So we don't have to take account the friction one, the friction forces. Now let's move to the free body diagram number 2. So this is how it will look like. So basically, to simplify the free body diagram number 2, yun pa rin yung gagawin natin. We will rotate this one in such a manner that we will have these, the one I highlight, to be the x-axis and these to be the y-axis. Okay, so yun pa rin yung gagawin natin. So I'm just going to undo that one. So that will give me a free body diagram like this one. So ginagawa natin na ganito, class, because it's simpler for us to track the forces as well as the directions. But it's fine if you're very used to this. Tapos ito na yung bibigay mo na free body, okay lang sa akin. So for the mass 2, you need to know that the normal force is situated or directed perpendicular. So that is, like 90 degrees with the contact. So directed upward. Kasi nga, sa sinasabi ko, we will rotate this. Illustration here. So sa nakikita nyo, the normal force will be towards the upward direction. Tapos yung weight nyo, in this case, this one, is already having an angle at 53.1. Okay, so yun yung gagawin natin dito. So yung weight nyo will be here. I'm not really measuring the angle, but yeah, that's 53.1. So this is your weight sub 2. And then another force that exists is tension 2, which is directed towards the left. Okay, so that's your tension 2. Did we take into account? Yeah, I guess we're good to go. Okay. Another thing also is to note na yung direction of acceleration mo ay papunta dito. Kasi this will be very essential in checking the direction or the sign of the acceleration later. So once we have the free body diagram set up, so we have to work with the summation of the forces. So for mass 1, the sum of the forces along x is equal to mass 1, acceleration 1 along x. So what are the forces that exist along x? So you know that is just tension 1 is equal to m1. Tapos the acceleration 1 along x is actually negative since it's directed towards the left. So this will bear a negative sign, a1x. So t1 minus negative of m1 a1x is your first equation. So you call that one as your equation 1. Now let's try to deal with the sum of forces still on mass 1 but on the y direction. So sum of the forces in y is equal to mass 1 acceleration of 1 on y. Now if you look into that one, I'm hoping you do realize that there is no acceleration along y, or that is just 0. Because if I'm going to rotate it in this manner, and take note that is how we represented our problem, the acceleration is towards x. So nasa ano talaga siya sa x. X talaga na coordinate axis. So there is no acceleration along y. That means to say that in our equation that we set it up, or we are setting up here, the acceleration along y will be 0. So that is very helpful to simplify our equation. But what are the forces on y on our mass 1? So we see that it's the normal force. Normal force is present, so it's upward direction on y, so that will be positive n. And then, okay, Yeah, sorry. I missed something here. So, my bad. Nakita na ko class that I actually forgot that x component. So T1, meron pa pala siyang, what's this? The negative, no, the x component of the weight, and since that is on the negative portion of x, or I mean, nandito siya sa left-hand side sa x, so that will bear a negative sign. So we have negative W1 of x is equal to M1, and then again, negative A1x. The negative implies that the acceleration is moving towards the left. So what will happen is T1, and then if you note, 30 degrees is our angle, and W1x, meaning the x component of weight 1 with respect to 30, they are opposite. So opposite means the sine function, so that will just be minus 1, the sine of the angle, which is 30 degrees, is equal to negative M1A1x. Okay, so this is the correct equation. So forgive me, I forgot to take into account the x component of the weight. So let's proceed to the y, to the sum of the forces along y. As I've said, this will just be 0 for reasons stated earlier. So it'll just be 0. So this will be a simpler equation to deal with. But what are the forces on y? We have the normal force, and then your weight. The sign of the weight will still be negative because, as you can see, it's directed in the negative y-axis. So minus w weight 1y, meaning on the y-axis, is just equal to 0. And then, of course, as I've said, once the x component or the other component is given by sine function, it's automatic that the other component of your weight, in this case, should have the alternate niya na trigonometric function. If this is sine, therefore, the second one will be given as W1 cosine of 30 degrees is equal to 0. So this is your equation 2. So this will be your equation 2. And I think this will not be very helpful for the problem. But let's just write it there. Maybe it will be helpful. Just maybe. So for mass 2, this will be your sum of forces along x is equal to M2 A acceleration 2 along x. So if titingnan mo siya, yung forces along x, we will not forget that may component na si W2. So W2 sub x, dito si W2 sub y, yung y component of weight 2. Now, isa sa forces na nakikita mo is your T2, which is directed at negative. Kasi papunta siya sa left-hand side where the values of x are negative. So negative T2. And then yung x component mo, so take note, your x component dito, opposite lang siya sa 53.1. And we know if it's opposite, so it's the sine function again. So, ang mangyayari, since it's on the positive side, yung W2, papunta siya sa right-hand side dito, where the values of x are positive, so positive din yung sign niya. Plus, W2x is equal to negative M2. Okay, para hindi kayo ma-confuse, susulat ko na lang M2, tapos yung A2x niya, since papuntang left, that will bear a negative sign. So, negative A2x. So, isi-simplify ko lang. I have negative 2, and then for this one, I have plus weight 2, and opposite pa rin. So, sinasabi ko sine pa rin. So, sine of 53.1 degrees is equal to the negative of M2 A2x. So, ito yung equation 3 na yung makukuha. So, I will note this one that this is my equation 3. So, we lack one equation na lang. So, we will get the sum of the forces along y. So, taking the summation of the forces along y will give you ano yung forces na nag-exist. First, we know that meron tayong normal force. Sorry. I should write it first as M2 acceleration of 2 along y. Okay, and the same reasoning that we had before, there is no acceleration along y because of the fact that your system is actually moving horizontally along x. Wala siyang acceleration along y. So that will just be 0. And what are then the forces present in y? You have the normal force, which bears a positive sign since it's moving up. And then another one is the y component of this one, the y component of your weight. Since it's downward, along the y-axis, that will bear a negative sign. So minus W2 of y is just equal to 0. And we already use this one sign. So as I've said, if it's already signed, the other component will be the, I don't know if I should call it opposite, but the other component, if it's signed, should be cosine. So we have n minus omega 2, the cosine of the angle, which is 53.1 degrees, is equal to 0. So this will be your equation 4. But I think these two equations where you have normal force is not so much helpful for this problem. I just think. So here, we are dealing with these 4 sets of equation. And as you can see, another consideration that you should ask yourself, you should be able to answer the question or of this one. This is what I've said earlier. Is T1 equal to T2? So try to analyze. So the answer is they are just equal. So T1 is just equal to T2. So what happens then is I will just set T1, either T1 or T2 equal to T. They are equal for the same reason that we mentioned from the previous video, that basically they are just connected with the same string. So whatever the pull of the other one, that will also be experienced by the other body. So yung T1 mo dyan at saka T2, they are just equal. So I am setting them just equal to T. And another consideration that you should note is lahat ng acceleration will be equal. So ibig sabihin yung A1x ko dito, may A2x ako dito, they are just basically equal. Kasi nga, connected sila by a string. So whatever the magnitude of acceleration by the 100 kilogram, that will also be the same acceleration na may experience ni 50 kilogram. So sasabihin ko dito that A1 is just equal to A2. So lahat ng A1 or A2, that will just be represented as A for brevity. So ngayon, ang kukunin natin is yung acceleration ng ating blocks. So it's very obvious na ang magagamit mo lang na equation is equation 1 and 2. And if you notice previously, ang ginagawa natin class is we did some substitution. So dito, mas efficient gagawin kung ang ating gagamitin rather is yung elimination. So yung T1, sa sinasabi ko ang T1, masusulat ko lang yan or pwede ko yung isulat as just T since that is just equal to T2. So T minus the W1, the sine of 30 degrees, is equal to negative M1 at saka yung A1x, sinabi ko na kanina that could be just be represented as A. Kasi nga equal lang yan. Yung A1x, yung AX, yung AY, they are just the same for both object 1 and 2. So i-A na lang natin para madali. At saka yung T2, susulat ko yung T2 beneath this one. So yung equation 3 rather. Yung T2 na sinasabi ko kanina, that will just be written again as just T. Pero negative T yan. Negative T, tapos plus W2, tapos the sine of 53.1 degrees equal to negative M2 at saka yung A2x, sinasabi ko na kanina, that will just be A. So this time around, ang gagawin ko lang class is, sa sinasabi ko, elimination ang gagawin ko dito. Kasi siya yung pinaka-efficient gawin. But you can still do substitution. Yung normal na ginagawa natin, that means you express, for example, you express T1 in terms of all of these terms. And once you get the value of T1, for example, T1 is negative M2 A2x minus W2 blah blah blah, ipa-plug in mo lang siya dito. And you will still get the same answer. But for this, it's more practical to use elimination. So if you try to look into this one, T plus negative T, that will just be cancelled out because that will be 0. And what will be left is this one. We will be left with negative W1 sine of 30 degrees and then plus W2 sine of 53.1 degrees. And then sa taas, meron tayong negative M1A tapos plus negative M2A. So sa nakikita nyo, I could simplify the right-hand side. I'm just going to, maybe I could do it in this way. Negative W1, the sine of 30 degrees plus W2 sine of 53.1 degrees. And then ang gagawin ko is I will factor out A, or I will factor out negative A na lang. Negative A, para ang matira is this one. M1 tapos plus M2. So yun yung reason kung bakit negative, if na-factor ko din yung negative para positive yung M1 and M2 ko. So check daw, M1, okay, tama. So ngayon, since we are looking for A, basically, ang gagawin ko lang dyan is simple. It's very simple. I will multiply both sides of the equation. I-multiply ko siya by the coefficient, itong number or itong variables na nasa side ng A. So, multiply both sides by 1 over M1 plus M2. And when I do that, this portion here will cancel out, leaving behind A. So, ngayon, ang mangyayari, meron akong negative W1, the sine of 30 degrees, plus W2, the sine of 53.1 degrees is equal to negative A na lang dito, negative A. And if I don't want to have negative A, ang gagawin ko lang is multiply both sides by negative 1. And rearranging, I have A is equal to this one will be positive, W1 sine of 30 degrees. And when I multiply this term by negative 1, that will be negative W2 sine of 53.1. Pero wag mong kalimutan that since you multiply 1 over M1 plus M2 both sides, dapat meron din si M1 over M2. Those terms above is divided by M1 over M2. So this will be divided by M1 plus M2. So ang mangyayari is basically ganito lang. Yung weight 1 mo, that is M1 times G, tapos the sine of 30 degrees, tapos yun lang. Basically, I'm just expanding yung weights nila. So weight 2 is M2 times G, sine of 53.1 degrees, and that is divided by M1 plus M2. So that will be your A. Now, if you are going to calculate that one, you should be getting a value close to 0.654 meters per second squared. So ito yung acceleration na masosolve mo. That means this is how fast your two blocks are accelerating. And this A, again, as I've said, I'm emphasizing na equal yan for both mass 1 and mass 2 since connected siya by the same string dito. Okay? So, yun yung acceleration na makukuha mo. And if you are going to check if indeed, madali lang ba itong makuha, kung titingnan natin, class, M1 given, G, this is a constant. Of course, sine, makakuha ka lang ng constant dyan. M2 given din, constant, given. So, kaya napakadali lang kunin yung acceleration kasi isang unknown lang si acceleration lang siya dyan. So, yun yung makukuha mo na acceleration for your problem. So, let's check this one that we have or we are able to find for the acceleration of the two blocks. And we argue that the acceleration will be at least in magnitude the same. Okay. So for the third problem, for the third part of the problem, we are asked to find for the tension in the cord. And we know from argument stated earlier that the tension 1 is just equal to tension 2. And we just denote it by T. So ibig sabihin, from the four original equations, I could just choose whether 1 or 3 kasi yun yung equations na may T na T variables. So for my case, I will be working with 1, but it won't matter if you will use equation 3. You will still arrive at the same answer. So from equation 1, I will be getting this one. From 1, T minus W1 sine of 30 So W1, the sine of 30 degrees, is equal to negative M1. Negative M1 A1x. Sinabi ko na kanina, yung A1x, that is just equal to A kasi nga the same acceleration lang sila. So, ang makukuha ko na tension from this equation will be like this one. T is equal to negative M1A plus W2, it's W1 sine of 30 degrees. So if I'm going to expand this, I have negative 1a plus m1g sine of 30 degrees. Tapos if I'm going to factor out again yung m1 mo, so magkakaroon tayo ng wait lang. Plus, okay. So if I'm going to factor out m1, I will get negative a plus g sine of 30 degrees. So, eto na, I'm just going to plug in the values. M1 is 100 kilograms. Tapos, yung A ko is negative 0.654 meters per second squared plus G, which is a constant at 9.8 meters per second squared. And then the sine of 30. So, I'm hoping you remembered yung unit circle that the sine of 30 is just 0.5 or 1/2. So, yun. Okay, I don't know why there's a line that's formed. Okay, yun. So, continuing with this one, you'll have T is equal to, let me just get my calculator, 100 multiplied by 0.654 plus 9.8 times 1/2. Sorry, 1/2. And that will give me a value of tension, 654 plus G times 1/2. Okay. So, yun. Wait lang. It's negative pala, negative 0.54. So, I should be getting a value of T is equal to 424.6 newtons. So, obvious naman siguro na newtons talaga ito kasi if you look into this one, you have kilograms. This is kilogram, and then the answer of this quantity in parentheses is just meter per second squared. Meters per second squared, this is meters per second squared. So, that is really leading you to a unit of Newton, which is a unit for tension. So, ibig sabihin, yung tension mo, which is the same, dito, yung T1 at saka T2 mo dito, is at 424.6. Ito silang dalawa, 424.6 in magnitude. Now, if medyo hindi ka confident sa iyong answer, you could actually plug in class check. Since alam mo naman yung values ng T1, ito, masosolve mo lang din, give it, na-solve mo na din yung acceleration, check either of these equations, tapos makukuha mo talaga na mag-i-equate ang both sides of the equation. And if that is so, then you are sure that your answers here for acceleration and tension are actually the correct values. So that is how you will check. But I will not show it here since I'm expecting that is something that you already learned from your high school.